Hello, this is Britton LaRoche with Confluent. Today I'm going to talk about the very first step in creating a real-time generative AI application using Retrieval-Augmented Generation. It's a lot of words, but we have a GitHub here that I'm going to kind of walk through and explain some of the principles behind it. Retrieval-Augmented Generation is where you take your data, your personal private data for your company or for your project, and you marry it to a large language model. Large language models are typically trained on public data, but they don't have access to your private contextual data. And when you get this marriage between the two, the important thing to do is enhance the LLM with what's known as prompts. And the prompts are related to a semantic search that goes against a vector database. It's a lot of terminology, but I'm going to walk you through what all it means and then how to actually do it with the Confluent Cloud, connecting to a vector database, connecting to the Confluent Cloud. And the very first step, of course, is getting data from other data sources, vector encoding it, and then putting it into a vector database. Well, we did a lot of words here. Let's talk about it. What is a vector? Well, a vector is basically the way a computer looks at meaning. So you can actually take something in natural language, and then it actually goes through and converts it to a floating point decimal. So if I say something like a quick brown fox, well, a quick is basically a dimension of speed. The color is a dimension of color, it's brown, and then animal dimension, fox. And so a fox is very similar to a cat or a dog. And if I were to store these numbers, they'd be very similar to each other. If I were to query the database using what's known as a k-nearest neighbor, looking at similar vectors that are very similar in numeric values to sine or cosine or dot product or however you want to do it, these things are very close together. It'll actually retrieve those back. So here's an example. Find me a red summer dress in medium size. And so this query is converted to a vector. The vector is used to search a vector database of clothing items. And these items are used to create a prompt for the LLM. The LLM generates its response with a specific and accurate recommendation for the user. So an example is, if I were to search for a Macintosh is a raincoat. If I would just search for Macintosh against the clothing database, I may get some other things. But the meaning behind it is it's possibly raining outside. So a vector search, a semantic search going against a vector database would actually pull back things from your clothing and apparel that may or may not be what you would expect from a full text search. For example, it may show you umbrellas and galoshes because the meaning is I want to prepare for rain. And so you would get a different search result off of text versus meaning. And so vectors are very important for generative AI because it goes after the meaning behind the words, not necessarily how the words are spelled. So that's huge. So we're going to go ahead and talk about this. This is a whole thing on what generative AI is. You can click here and take a look through. But the idea is that we're actually going to go through and do the very first step, which is creating and hydrating a vector database that you can search against for your prompts. And the way that we do that is through what's known as data augmentation. So we can take data that's coming through an unstructured data source, or perhaps a relational database. We have connectors for all these things. You can also have custom producers produce this information to a Kafka topic. The data flows in, our native connectors that we source and host in the cloud, fully managed, work with pretty much every major database. And it's able to capture the changes as they occur in real time against that database and put them into Kafka. And it does so in such a way that you don't need to have an agent running on the database. You simply provide the connectivity information like username, login, password, and access to the data that it needs to query against. And that's all that needs to be done. And so when the data flows in real time, the next thing that we need to do is vectorize that data. And we're going to do this in this particular lab, in this particular demo. So we will actually use what's known as FlinkSQL, which is also fully managed. And I'll show you how to set that up and configure it. When this data comes in, FlinkSQL reads the data and then vector encodes the content so that you get a vector back to Flink. Flink then inserts the content and the vector into a new topic that is synced through a certified connector, also fully managed. In today's use case, we're actually going to use MongoDB as the vector database with the vector Atlas Vector Search capabilities. And I'll show you how to set up this connector as well. And it goes straight into the vector store. And I'll show you how you can add an index to MongoDB to do your Atlas Vector Search. All of this right here, right now. The interesting thing is that this is all real time. And if you don't do it real time, then typically what people do is batch processing. And it's more than one database, but multiple databases. Everything that you need needs to be vectorized and put into a vector search. If the data is already in Kafka, it's very simple, it's real time, and it flows nicely. If it's not, then you have many point-to-point integrations you have to maintain in batch. And the batch itself is slow. And is that a problem? The answer is yes. Even if you microbatch every 5 minutes, you can imagine a scenario where you're at an airport during a winter storm, for example, and flights are being canceled. And you book a flight, and because it was on a batch process, it was already canceled, but you didn't know it. 5 minutes later, you find out your flight is canceled. That's not a good customer experience. If, on the other hand, they were using the Confluent Cloud in real time, when they book the flight, they know exactly what flights have been canceled and what hasn't. The LLM is prompted with the right information, not stale, old information. So the way we start is with the data gen connector, and we're going to generate some data. Typically, this particular source right here, I could show you how to connect to Oracle, but for the sake of keeping it simple and being able to keep it all in one location, we're going to generate some data from what we call a data gen connector that we provide. It's just sample data. And once we create that, we're going to go off and create the Flink information. I'll scroll through this stuff. I'll show you how to set up Flink as well. So these are the first two steps I'm going to walk you through. So here's the Confluent Cloud. When you log in, you're typically here. You can click either on Confluent Cloud and see the environments, or you can click on this environments menu item on the left, and you can see all the different environments that are available to you. Now, I'm going to go ahead and create a new one. We call it GenAI demo. And I'm going to go ahead and create this environment. And it allows me to set up a couple of things. One is data governance, which allows me to generate a schema And that's important so that I'm able to vectorize that. I know all the data types and all these things, so I can put it into MongoDB and other databases. So that comes for free as part of a basic configuration. I'm going to select the cluster that I want. I'm going to put it in AWS next to my MongoDB instance, which would be in Oregon US West 2. And I'm going to use a single availability zone. This should be a free tier. Everything should be good. I'm going to go ahead and say continue. You can follow along with me at home, no problems. So this cluster, I'm going to call it retail POS. And we're going to actually set up a retail cluster with retail data coming in. I'm going to go ahead and launch that cluster. And when I do so, it should create this cluster in the background. Now, as that's happening, it'll actually come up to speed pretty quick. We can actually take a look at the environment that was set up. When I created GenAI demo, there's a couple of things. One is the schema governance I was talking about. It gives you an endpoint to connect to the schema registry, and you can create an API key to log in and access the schemas. All this is baked inside Confluent, so I don't have to do it. I just want to show you where it is. The next thing that we have is the Flink thing. So we can create a Flink pool. We can look at the Flink statements that are running, and I can generate API keys. So what I want to do is create a compute pool. Now, when I do this, and I see this little thing going here, it's typically because some things are running in the background of the process. I'm going to go ahead and just log out, and then I'm going to log back in. So sign out, and we will sign back in. Next, I'm doing this so that you can actually see this may happen whether or not you expect it, but sometimes there's certain things that need to be reset when you create your environment. So log out, log back in, refreshes everything. Now back in, we'll go back to our environment that we just created, create a compute pool, and it's right now everything is ready to go. We don't want Mumbai. We want to create it actually in US. I'm going to cancel this. I'll start it again just so you can see the process. I want to, it picked up right where we left off, but I want to actually be able to go through and see. It's interesting that it's taken me to the beginning. Let's go back to the Confluent Cloud. I could have continued from there, but I wanted to show you the full flow. So I'm going to go back to GenAI demo, and I'm going to go to Flink, compute pool, create a compute pool. Right where we were, but I just wanted to show you that path. So here we go to Oregon US West 2. I'm going to click continue. Everything's going to be together. The Flink pool, my Confluent cluster, and the MongoDB database. It doesn't have to be that way, but for simplicity's sake, for performance, and for cross-region traffic ingress and egress, it's cheaper, better, the way to go. Trust me, set everything up in the same region, and everything's fine. So here we go. It's running with this Flink pool name. It's going to be in US West 2. I'm going to go ahead and create that. It's going to take a little time to bake, and while it's baking, we're going to go and create our data gen connector and start having some data flow through. So we're going to go to my clusters. I go to my retail POC, and I want to create a connector. And here's a cool thing about connectors. When I say connectors, every major database you can think of, we've got it fully managed in the cloud. So Azure Storage Blob, DynamoDB, CDC Source, IBM MQ, HTTP, Oracle, Postgres, Microsoft SQL Server. The world's your oyster. We're going to just go ahead and do sample data. I'm going to load in some additional configuration, and I want to have some product data. So I'm going to add a new table, a new topic. In FlinkSQL, it shows up as a table, and the cluster we just created shows up as a database. So I'm going to create this thing called product. This is our new topic. I'm going to give it one partition, and I'm going to go into advanced settings. Now I can specify the retention period up to infinite if I want, a year, a month, whatever. You can even go lower. I'm just going to set it to an hour. It can be less than an hour. You can set these parameters through an API as well. I'm going to set it to an hour and 1 gigabyte. So, and then after that's going to delete. Nice and tidy, very clean, good for a demo. So I'm going to go ahead and save and create this. And then I'm going to select my product updates. That's great. So we're good to go. Now I'm going to say continue. And it's going to say create or select an API key. Now, you can actually create one for a service account. That's the proper way to go for production. But for this demo and for the development purposes, I'm just going to create one for my particular API key here, and I'm going to download it. So I copy these values, and I'll put them into my notes here. And we're going to use this later, and actually in the very next step. So it's a good idea to go ahead and copy and paste this into a notepad or something where you can get access to that information quickly. Make sure you click the copy button, make sure it says copied. And then we go point, and we're in. Okay, good. So that's good. I've saved this off. It's also downloaded. I can actually go to my downloads up here and find it with the API key. Not a problem. I'm going to go ahead and say continue. We're going to use JSON with schema registry, and I'll show you what the schema looks like in a second. We're going to provide our own schema. I go back to our data gen source connector, and we have this product schema that allows us to go ahead and put the data in. And all the steps I just went through, I've got little screenshots out there to help you go through it as well. But it's nice to have a video you can follow along with as well. You can pause it, stop it, replay it. So we go ahead and put this in here, and we've now defined a schema for products and all that good stuff, for properties, the color, the type of string, etc. Now I've specified different, data gen allows you to generate random numbers. So I've specified different random things that can happen, or a min and max, or an incrementing sequence key, those type of things. It's really helpful for POCs and test data. A lot easier than setting up another third-party product. But if you do have one, a third-party product, I highly recommend Shadow Traffic. You should check that out. It's by a former Confluent employee, and it's great. A very good tool. So you'll hit continue. The purpose of this, I'm just going to keep it real simple. One topic, one task, everything's good. I'm going to go ahead and say continue. And then we get to name it. So I'm going to call it data gen source product updates. So we know what it is. It really gets confusing when you have connectors 0, 1, 2, and 3. It's nice to give it something where I know that this goes to this topic. I'm just going to call it by that name. And then it says topics, configuration costs, JSON SR, yada, yada. Looks good. I like it. Here we go. Off to the races. Oh, did I put the, I think I put the key in there. I can't remember my brain. But anyway, so it should be off and creating connectors created. In a minute, it should be provisioned, and then we can actually see this data showing up in topics. Let's take a look. There we go. It's up and running. It's great. So I can actually go into it and take a look at the bytes being produced and everything, or I can go over to the topics, product updates. No data has come in yet. So I'm going to go back to my connectors. So I'm impatient, just like I hit an elevator button multiple times, thinking the elevator will come faster. The connector is running. I'm looking for throughput. Not yet. Okay. So we go back to the topics. And if I go to product updates, I can actually look at the messages and we can see them flow in as they come. Here they are. We got it. So I take a look here. There's my store ID, extra large shorts, price. Notice that price. It doesn't look like something we can read. I forgot. I should go in and set the single message transform when we create the connector. But I can do that here as well. So go back to the connectors. We go to settings. We're going to add a single message transform, add an SMT. We're actually going to do it on the transform type and cast the value to price, which is the price of things that are coming through. We just saw that, to a float 64. And that is the way we handle it in Kafka land with JSON schema registry. Great stuff. We're good. I'm good with that. I'm going to go ahead and save the changes, and then I'm going to apply these changes. Now, while that's baking, I'm going to go back and take a look at the Flink information. As it applies these changes, it should actually go through and update the topics. New data, we'll actually have this. The old data, after an hour, will be purged out. And really, it's going to keep that data type correctly. It's mainly just so that we know how to represent this in a GUI or something else selecting from it. That's important, but it's not critical. It'll actually show up the right way in the database, and we'll see that in a moment. If I go to product updates, it's also important to do it when you're set the connector. We'll do that for Mongo as well. So I go back to the product updates messages. Now, if I take a look, so it hasn't come in yet. Next one, still not working yet. All right, I'm gonna let it be for now. We'll come back and check on it in a bit. I don't know if I'm seeing old data or there we go, 8096. It takes a while. All that old data you can get rid of, or you can just wait an hour. I typically, a lot of different ways to handle that when you're doing demo, but it's demo data, so it's not the end of the world. So we're gonna go over back to the high level, so GenAI environment. We're gonna look at our Flink tool, and now it's set up and ready. I can open a SQL workspace, which is great, but I also like to do the FlinkSQL command line because you can script this. You can add it to a CI/CD pipeline. It's got a lot of great value to it. So off we go. We're gonna go to command line. You typically start here, and you do a Confluent login, and I show you in the GitHub how to download the Confluent client, how to set it up and configure and log in with all the good stuff, give you all the documentation to it. And we're going to now paste, now that I'm logged in, I'm going to paste the command that is the Confluent Flink shell. I copied that from that environment. It sets up the environment where we can actually go in and take a look at it. So I'm going to execute that. I'm now connected to Flink. This is great. I'm going to say select star from, and then I'm going to backtick it, product updates. Now, the reason I did the backtick is this is a literal quote. In database land, you typically SQL land, you do an underscore, not a hyphen, but I like to be difficult and just show how it can be done this way. So I select star from product updates. It says you don't have permission to access it in catalog GenAI demo, and the current database is not set. So what do we need to do? Let's take a look. Let's go back here, and I did this on purpose just to show how everything is. If we take a look at GenAI demo, we have a retail POC cluster. This is the database. So you have to go back, and I wanted to show you what the error looks like. Use. There you go. It kind of knows what I want. Retail POC. That tab, retail POC. It is highlighted. Everything's good. You use the down arrow key. We use retail POC, and it says, okay, now we're good to go. So now I'm going to go back, and I'm going to select start from product updates. Now it's ready. It's going off to be pending. We're going to wait just a second. It's going to fire up a bunch of resources in the background. It's connecting to the Confluent cloud. It's pulling the data out. And then once it's up and running, it's up and running. You don't have to do this ever again. And if you leave it, if you exit out, it'll stop the Flink statement from running. But if you leave it going, it's going to keep submitting that over and over again. I'll show you the Flink statement running, and then when we exit out, I'll show that it stopped. And I'll show you where to look for that. So give it just a second. Almost there. Boy, this is typically it's done pretty quick. All right, here we go. We got the age group, price, and season. Once the data comes in, it just keeps flowing through. This is really setting up the back-end processing. So when you do that for the first time, it takes a while. And now we can see everything. Socks, green, female child, $86, $29. All the good stuff's coming through. It looks good to me. So I'm going to hit the Q button. You can press Q at the bottom to quit or Control C. And then it says aborted. And I forgot I was going to show you it was running. Let's go back over here to Flink. And I look at the Flink statements. We can see that one was stopped and one failed. That was the first one where I just selected and it failed. This is the one that stopped. I can click on it and I can see what was running. It's very nice. And I can clear them out. I can like delete them or whatever I want to do. But for now, what I want to do is go back and do some more stuff. Let's go take a look at the GitHub. It shows you how to do this good stuff and what we just did with the Flink compute pool, how to do different things with commands. This is where we logged in. Now we're going to do something really cool. We're actually going to set an OpenAI key as a secret, and then we're going to execute that. And we're going to connect to the vector embedding service, like of OpenAI at the endpoint. And we're actually going to call the vector embeddings. We're going to create a model function that we can reuse. The first thing I'm going to do is copy this information over, go back over here. I want to do something real quick. I'm going to show functions. If I show functions, you can show tables, you can show different things. If I show functions, product updates is acting as a table, but it's a topic. The database is a cluster. So it's just a mapping. You can run SQL against a cluster and a topic. It's very cool and fully hosted for you. So if we took here, we have ML Evaluate, ML Evaluate All, ML Predict. These are first-class citizens built into Confluent Cloud's fully hosted Flink SQL product that is for you. And you can actually do full-on GenAI applications using these functions. And this is the first step, so I'm going to show you how it's done. If I hit return at the bottom, I want to set my OpenAI key. And I hope someone blurs this out because I love my OpenAI key. I don't want to give it out. It's cost money, my own money. And I can't help myself. I love messing with GenAI stuff, so I pay for pretty much everything. Midjourney, you name it, I've got it. I'm playing with it. So I set the secrets to this value, and we're off the races. It's good. So the next thing I need to do is create my ML model function. Now, when I go back and look at this, I'm actually creating a model called vector encoding, and this is what I call the model. In the ML model function, I have to pass in the name of it, and we'll do that in a moment. But vector encoding is what we need. It has an input of type string, it has a vector, an array of float, and so that really is the vector embedding returned to you from the embedding service. The task is classification. The provider is OpenAI. This is the endpoint that you hit OpenAI for vector embeddings from Python, Java, you name it. That's where you go. And here's my OpenAI key, right? So I hit enter, and it completed. It's good. So now I can do vector encoding on my data right now, and we're actually done at this point. The rest of this tutorial is showing you how to enhance this and sync it to the database. We're actually really done with the main point of this tutorial. We're actually going to go and select star from products updates. And I'm going to do a lateral table, ML predict, and pass in my vector encoding function I just created, and the content that I want to be vector encoded. In this case, I'm just passing in the content type, gloves, shoes, shorts, belts, things like that, only as a demo. So we go ahead and do this, and we're off. So the key here is that we want to be able to search on more than just the content type or the article type. I want to pass in content that gives me everything about the product. So that when I do a vector search, I can find other products like it, or I can find the same product in another store, all these different ways of looking at how that product may be used. I want to find that red summer dress, whatever, I'm able to do that. I'm able to look it up, or Macintosh or whatever. It should give me things that are very similar to that in meaning. So raincoats and rain ponchos, Macintosh, all those things should show up if I do a search for Macintosh. So here it is. The article type has been passed in, and the vector encoding is coming back. This is great. To get this into a vector database, I want to do two things. One, I want to create meaningful content. And two, I need to sync it to the vector database with the vector. I got to create a new topic for that. So what I'm going to do is the next two steps. I'm going to create a table called product content. I'm going to make sure it's of type JSON registry. The first one is JSON SR. I'm going to keep this going through. If you don't specify it, it defaults to Avro. And then when you set up your connector and you think it's going to be JSON SR, you're going to wonder why everything's going to the dead letter queue. I warned you. Just make sure you keep this together with the same data type. The data types are important for the connector. And the schema is important as well. So JSON registry, we're going to create the table for product content. That's good. We're off, and we're ready to go to the next step. We actually go in here and we look to this insert. And what I'm doing with this insert statement is a SQL statement against the data that's coming into product updates. And I'm concatenating the size, the age group, gender, etc., to create a content that has meaning, more meaning than just the article type. You can do anything at this stage. You can join to other topics, and you can enrich this data to have the exact content that you want to be vector encoded for your product or for your flight or for whatever it is that you're going up against. So we click copy, and then I put this over here, and I'm going to kick it off. Now, the interesting thing is, go ahead and convert tab spaces. From product updates, that's the insert statement that I have. When I kick it off, it says waiting for statements to be ready, statements in phase pending. We're going to flip over and we're going to watch this. Back to the Confluent Cloud, looking at my Flink statements. When it starts running, we should see it pop in here. The interesting thing is, because it's an insert statement, it will always run in the background. I don't have to worry about when I hit escape, it's not going to stop it. It's going to actually let it go. And so I can actually see what the statement is. And this is my insert into product content. It's all there. It's all nice. You know what's going to happen. Now it's running. Okay. So I can actually go back. I can stop or whatever. When I disconnect over here, it's going to press enter to detach. It's going to keep running. And I can, it's great. You can do this through the GUI, you can do it different ways, but I like it via command line. This thing's up and going. It is going to continue to run in the background. You don't have to worry about it. Fully managed, all that good stuff. Now I can go back to my clusters, and I will look at my topic. I've got a new topic that I created as a table. It creates a topic in the background. I go to topics. There's my product content. And as I look at my messages, I can see I have data coming in anytime now. There we go. This one. That's all I need. And we can actually see the content is medium child, summer casual, Hagar pink boots, blah, blah, blah. This is a lot more than just boots, right? So this should make a decent first pass of creating a vector that I can search against with a semantic search to prompt my LLM. Good stuff. Now, we've got that going through. The next step is we need to vector encode that and put it into a topic that we can sync. So we have that going. Now I'm going to create this table called product vector. And you notice that what it's doing is it has the content, which is a new string we just created, and it has a vector, which is an array of floats. That's what we need to actually do the vector encoding. So we'll go back and create that table. And it's good. So the table and topic have been created. Go here. And now we're going to insert data into the product vector topic. So go over here. and it's pending, and then it will be, because it's an insert statement, it'll be running in the background. This statement is actually going to hit OpenAI using my API key and vector encode everything. We're using the short embedding by default, but you can specify Eta02 or whatever vector encoding you wish to use. Just be consistent with your vector database. You don't want to have a mix, because it's the vector encoding should be consistent for that particular thing, like products or product updates. It should always be the same vector encoding with it. Like you can use Hugging Face or what's the other ones? Bedrock or Claude or whatever it is that you want to use. I think there's another one that's out there. SageMaker. All the different LLMs that you want, they all have their own way of encoding their vectors, and they will encode your data for you. So what we're doing is, yep, we've got that. Oh yeah, this is the last statement that we had. We're going to go here to the Confluent Cloud. We're going to take a look at our topics. And I should have a new one called product vector. It said something funny. Maybe take a look at messages. Looks good. Yes, so I have the vector. Everything is good. Why did it look funny? You see topics? Oh, it had a little thing that made me think it was probably just starting up. So that's good. Everything's good. Now I want to go and I want to sync this data to MongoDB. So let's do that. Here's my MongoDB database. Let's go with my databases. I've got this little cluster 0. I want to look at the collections. So what we got? We got retail and we have product. Retail and product has nothing in it. So no documents, nothing there. I don't even have to have this. The connector will create it for me depending on how I set up MongoDB. But typically MongoDB, if you start writing to a new database and a new collection, it'll create it for you. I went ahead and created those two, retail and product. And I'm going to go to back to my Confluent Cloud, and I'm going to create a new connector for MongoDB. So we go to our cluster, and I go back to connectors, and I'm going to add a connector. And I'm in MongoDB. There we go. I want a sync, MongoDB Atlas sync, which happens to be popular. And then we say, where do we want? What topics do we want to sync? I just want the product vector, so I'm going to say continue. It's going to say, I'm going to use an existing API key. I've already generated one, so I'm going to reuse that one. And that is this little guy here. It's the one that we started with. API key. And here's my little secret. And now we're good. Continue. Okay, so I need to have the connection host, the connection user and password, database name and collection name. So the connection host I get from MongoDB, and I go back to databases, and this little thing right here, it says connect. And you can say drivers or whatever you want. It's this little piece right here that you need. And it took me forever to figure that out. You don't need the whole darn thing. You don't need to do the SRV, just the host name. All right, so you go back in here. It's the easiest way, easiest thing to do. So that makes it easy. I have a written user, and I have my secret password. And then I have a database name. It's called it retail. If I misspell it, it'll create a new database. That's fine. Retail, and I'm going to call it product. And then I'm going to say continue. Now I could go in. Yeah, that's fine. That's my password. It's very strong. It's a demo. So I could go and take a look at advanced configurations. So we'll go down to transforms. I like to keep things easy and all the good stuff. We're going to cast the value of price again. And I'm going to cast it to float 64. Oops. No, not drop value. Cast value. And I'm going to specify price. And again, float 64. There's other different databases, different things. It'll be different. You'll have to look at the documentation, figure it all out. But I think that's the right way to go. So thumbs up. And now I'm ready to create my connector and say continue. MongoDB Atlas Sync product vector. Ta-da! That's my connector name. Everything looks good. And I will now continue. We're almost there. So here we have it. As that's kicking off, I want to go and take a look at my MongoDB cloud cluster. I'm going to go to my databases, back to my browse collections, and I'm going to see retail and product, and we're just going to wait. Oh, we got it. We got it. We totally got it. Okay, so you notice there's a vector. This is the vector that's there. So now the last step, the very last thing I need to do is put that, I need to create a key, or a search index. Okay, here we go. So I'm going to create a search index. Where the heck do I not see? I do not see. There it is. There it is. Atlas Vector Search. Perfect. I'm going to create this. I want Atlas Vector Search. I want it in the JSON editor. So the fields, the type is vector. The path is the actual field name. Well, I called it vector, not to be confusing, but vector. Oh my goodness. All right, let's do that again. And the number of dimensions, I showed you that 1536. That is the number of dimensions that's returned. And I want this to be a dot product. And in doubt, always do dot product. You have Euclidean, you have all sorts of different things. This again. And I'm done. I've created my vector index against MongoDB. Now we just do a vector search. That's a whole nother topic. I'll show you how that's done, but you're done. The very first step of hydrating, maintaining, and keeping your vector database up is good. Anytime an update comes in, it will actually go through and update your vector database in real time. So updates are there, inserts are there, all the different things that happen to your products in inventory or flights or whatever are now vectorized and updated and maintained for you, hands free. It's all good. All right. So thank you for your time. I'm gonna go ahead and wrap here. Hope this was useful for you and hope to see you in the rest of